It's time to talk about the last condition for a fully simplified radical. For a radical to be entirely simplified, and I know we talked about the first two conditions yesterday, to be fully simplified, there must be no radical in the denominator. Today we're only going to be talking about simplifying square root radicals. We're going to talk about cube root radicals later. So bear in mind that when I talk about the strategies for reducing radical denominators, I'm only talking about square roots. The example we're going to start with is this: the square root of 9x squared over y to the fifth. So using the quotient rule that we talked about yesterday, our first step is to start simplifying by splitting it into a radical on the top and a radical on the bottom. Going from there, we can use the quotient rule to break it into multiple parts. So again, remember that we split y to the fifth into two parts, one with an even number and one that's just y to the 1. That way we can reduce this and leave this in the radical. Again, remember that this only is the strategy for square root radicals. We'll talk about cube root radicals tomorrow. Moving on from there, we're going to simplify the top first. So we can say the square root of 9 is 3 outside of the radical. The square root of x squared is simply x. On the bottom, we now have the square root of y to the fourth. Remember that this can be written as y to the fourth to the 1/2. So when we simplify that, we take 4, multiply it by 1/2. So when we simplify that, we get y to the 2 on the outside of the radical, and this is left over. Square root of y to the 1, which is just the square root of y. We cannot simplify that any further. From there, we have a problem. It is not fully simplified. Why not? Because it has a radical in the denominator. For square roots only, here's the strategy we're going to use. When you have something like this, you're going to take whatever is in this square root radical and you will multiply the top and the bottom by whatever is inside that radical expression. Since we just have radical y, we're going to multiply it by square root of y over square root of y. When you do that, this will just become 3x times square root of y on the top over y squared times the square root of y times the square root of y. Let's simplify what that looks like on the inside of the radical. We can combine this using the quotient rule again and put everything that's in radicals simply multiplying itself under one big radical. When you look at that, another way of writing y times y is y squared. So let's just rewrite the top, and on the bottom you have y squared. Y times y is now rewritten like this. Do you see where I'm going with this? If not, that's okay. Moving forward, we're going to rewrite it. 3x times the square root of y on the top, and on the bottom we have y squared times the square root of y squared, which again, as we remember, is saying y squared to the 1/2. If we multiply the exponents, we get 2 times 1/2, which is y to the 1. So over here, we're just going to have y squared times y. So continuing to rewrite it, we now have 3x times the square root of y all over, and let's combine these, remembering that if there is no exponent written, it's just y to the 1. We multiply y squared times y to the 1, meaning we add the exponents and get y to the third on the bottom. It is now fully simplified because there are no radical expressions in the denominator. By multiplying the top and the bottom by whatever is in the radical expression, we removed the radical from the bottom and moved it to the top. Now it's entirely simplified. Our new example is the square root of 25 x to the fifth over 32 y to the seventh. When I look at this, the first thing I want to do is ask myself, are there any common factors inside this expression that I could simplify first before I start dealing with radicals? It looks like there aren't. 25 and 32 do not have any common factors, and these are different bases, so this means that these two exponential expressions cannot interact. Let's start just like we did with the last one and split it using the quotient property of radicals. Once we've done that, we can split it again using the product property to get the square root of 25 times the square root of x to the fourth times the square root of x all over the square root of 32 times the square root of y to the sixth times the square root of y. Let's take a closer look at this because I noticed something here. This number here can be split up. We're going to rewrite it, instead of saying 32, we're going to rewrite it as 16 times 2. Again, splitting it using the product property of radicals. So starting on the top, let's begin simplifying it. The square root of 25 is simply 5. The square root of x to the fourth, remembering what we do always when we're square rooting, we divide the exponent by 2. X squared times the square root of x. Okay, so on the bottom, we're going to continue simplifying. Square root of 16 is 4. The square root of 2 we cannot do anything about, so we leave it inside the radical. Y to the sixth, the square root of that means we divide the exponent by 2, so we get y to the third power. And on the inside, we still have y left over. It's not fully simplified yet. We have a radical expression in the denominator which needs to be removed. So, doing what we did the last time, we're going to multiply the denominator and the numerator by whatever is inside that radical expression, in this case, 2y. When we do that, we'll get 5x squared times, and we're going to extend this radical using the product property of radicals to just put everything inside one big radical, 2xy, so just combining these two things, all over 4y to the third times the square root of 4y squared. So again, I just multiplied whatever's inside these radicals on the inside of one big radical, 2 times 2 and y times y. Breaking that down even more, I'm going to rewrite this so that I can simplify it. So then I'm going to get 5x squared times the square root of 2xy all over 4y cubed. Splitting this up, I can rewrite this as the square root of 4 times the square root of y squared. All I did was use the product property to break these two apart. Finally, take a deep breath, we're almost there. We'll just rewrite the top, 5x squared times the square root of 2xy all over 4y cubed times 2 times y. And that can be entirely simplified, nothing changes on the top, can be entirely simplified to 4 times 2, so we combine the normal numbers. 2 times 4 is 8. Y to the third times y to the 1, secret hidden there. We add the exponents and get y to the fourth. And we have completely simplified this monster.